There we go. Looks like we're live. Thanks everyone for tuning in. We have the famous trio here. I'm Dominik. I'm co-founder at Memgraph and CEO. We have our CTO in the house, who is also known as the King of Wild Boars, and our resident ripe avocado here, Ivan, is joining us from our co-working space. More problems with the sound like last time, but we're gonna power through it. We made some improvements, and hopefully everything is gonna be good. We prepared a bunch of content for you today, so we'll see how we go through it. Let's switch to my presentation. So today we're celebrating the launch of 1.1 MAGE that happened last week. There's a bunch of content on our website and docs and our blog, so go check it out. And I have to say that we've implemented some interesting improvements in MAGE. But first, for you who don't know what MAGE is, maybe Marko, you can tell us what something a little bit about MAGE.
Yeah, hi everyone. So MAGE is essentially a library of a bunch of, let's say, user-defined procedures and functionalities. We pick a quite interesting name because there are a lot of different spells in the library. So you can use these spells to do magic stuff. But yeah, essentially it's a library of a lot of functions in any programming language. At the moment, we support 3, C, C++, Python, and Rust. But currently, we are super focused on these dynamic / incremental / online graph algorithms. And we are expanding a lot on that side, trying to provide as useful algorithm as possible to everyone out there. I hope that's it.
Then also the question is, what are the currently available algorithms in the MAGE spellbook?
Yeah, since I'm not a good wizard, maybe we can check the docs.
There's always Memgraph docs to the rescue. Between centrality, by connected components, bipartite matching, bridges, community detection cycles. There's a lot of interesting stuff. Vehicle routing. Awesome. Cool. Let's go on. So the point of this entire spiel today is the celebration of MAGE 1.1, which shows us dynamic graph algorithms. So we implemented the PageRank community detection and node2vec as dynamic graph algorithms. Marko, how would you explain dynamic graph algorithms to someone who's never heard what dynamic graph algorithms are?
So yeah, the main point is with graphs, you have some kind of updates, and the graph is all the time expanding. And then the question is, how do you get these calculations as fast as possible, and how to run them as the new data comes in the fastest possible way. And then there is a whole suite of let's call them dynamic algorithms, but there are also words like incremental or online algorithms. And essentially the point is, whenever a new data comes in the fastest possible way with the least amount of compute possible, the results should be calculated and returned. Most of these things are based. There is a well-known thing called like random walk in the graph. So we are essentially traversing a graph randomly and then calculating some statistics. And most of these algorithms are based on that principle. Just different things are calculated. That's maybe the shortest I can say.
For me, it's always the frustration when I run an algorithm. Graph algorithms are notorious for its complexity. It takes so much time to get the results, and I have to spend hours and hours and hours, and then the data changes, and then I have to spend hours and hours and hours again. Like that's, for me, something that I don't want to do in 2022. And that's why I was so happy when our team developed these incremental algorithms that update on every change.
Yeah, most of these graph algorithms are computationally heavy, and you have to like visit the whole graph multiple times to recalculate, and that takes a lot of time. And with this dynamic approach, you can do like almost the same results, close to the same, but with much faster time.
Ivan, what's your favorite thing about dynamic graph algorithms?
Yeah, the fact that I don't have to wait 1,000 years for the algorithm to run. If it's, let's say, 100 million nodes or edges, that's definitely a plus point.
Awesome. All right, then let's see what's next on the SAS schedule. So let's dive into how the algorithms themselves work. I think it's worth spending maybe 60 seconds to explain kind of how it fits into the puzzle. So we have this data ingestion side, so where you can connect all of your data sources, blend them together inside Memgraph. We support Kafka, Pulsar, Redpanda. You can ingest historical data from MySQL, CSV, a bunch of other data sources. And when you connect and build your model inside Memgraph, you can actually run the entire Cypher query language, which most of the graph developers are used to. But the value is actually in the graph-based data science, which we implemented a lot of the algorithms inside MAGE, and 3 of the popular ones today we're going to show you. And you can bundle MAGE. There's a bundled version of MAGE and Memgraph together, where you can just simply have the image that is ready for you to use, and you can run the algorithms. And that's what we're going to show today. Without further ado, I think, Ivan, dynamic PageRank, can you show us something, a little bit of something that the DevRel team has prepared on that side?
Yep. My wonderful colleague Kate helped me come up with a demo application so we can show you how the dynamic PageRank algorithm works, what it's all about, and how useful it can be. Just as Marko already mentioned, it relies on random walks. The whole idea is that the PageRank is approximated by the likelihood of a random walk ending in a particular vertex. So the more random walks will end in that vertex, the higher the PageRank will be. And about the demo, here you can see the Docker Compose file, which services will we be running today. This is, of course, Memgraph MAGE. It's a Memgraph image that comes with the MAGE modules pre-installed. Zookeeper and Kafka just for the streaming setup, because we'll be streaming the data. The data set is actually going to be a very simple Twitter network. Here you can see the whole data model. It's users connected by retweets. So we scrape Twitter for tweets that had the hashtag Christmas and compile them into a network that we're going to be analyzing with PageRank, community detection, and we're going to be applying link prediction to it with the help of node2vec. Let's get back to the compose file.
That's a comprehensive demo. And where can people get the code?
We'll be sharing the link in the live stream description, so you can just check it out later on. We'll be also sharing it through our social media channels. You'll have plenty of chances to take a look at the code yourself and run it locally.
I quickly looked it up while you were showing this. So Memgraph Twitter network analysis. It has the coolest README file that you've ever seen, and the clearest set of description or instructions for starting it. That's a lot of descriptions, but if you have trouble, now I'm gonna plug discord.gg/memgraph. Just join our Discord community and ask us. or create an issue. That's it. Back to you, Ivan.
Yeah, there's always the option of something not working, so don't be afraid to hit us up either on Discord or creating an issue directly, whatever you feel like. So about the rest of the setup, okay, we are starting Kafka and Memgraph. The stream service is the one that's literally reading from the CSV file that we scraped the data into, and a producer is sending data to the Kafka cluster, Memgraph is ingesting it, and PageRank is being ran on the live data as it's being consumed. So the backend app is literally the simplest Flask server available. The only addition is that it has a WebSocket connection to the front-end app that's created in React, so that we can stream the data as it's being ingested. That's more or less it. I'm gonna start it up now so you get an idea of how it works. We created a simple startup script that you can just run. It's gonna stop all other running Docker containers. It's gonna build the images and it's gonna run them just like you would manually, but this just saves a bit of time. Now we're gonna have to wait a few seconds until everything is built and ready. In the meantime, I'll prepare the other command we'll have to run, and that's for starting the front-end app after everything else is powered up. In this demo, we'll be showing nodes being created, and the PageRank is calculated dynamically and assigned as a property to each node. And in the front-end app, the size of the nodes will be dependent on the PageRank. Pretty simple.
That's on the visualization. The size of these nodes will be will represent PageRank score. Yeah.
So the larger the node, the more important it is, according to PageRank?
Yep. That's the whole point, to visualize it.
Awesome.
Now let's see if we're gonna pick it up. Okay.
And
let's check Memgraph lab. Okay, so data is being ingested. As you can see, the number of nodes and edges is increasing. And okay, the app didn't break, and nodes are being generated dynamically and added.
Why would it?
Because it's always a possibility. Just to show you something else that's pretty cool. I mean, this setup, you can always use it for any kind of occasion. It's the v3.js library in combination with React, but you can do the same thing in Memgraph Lab without so much programming hassle. So if you check the README, we prepared a few styles that you can apply in Memgraph Lab. So this is the PageRank style. If I run a very simple query to return part of the network, so nodes and the relationships between them, I just limited them to 100 to make it a bit faster, and I apply this visualization, and as you can see,
much better.
Our Christmassy Twitter network.
Christmassy Twitter network. I like this. I like this much better than the plain unstyled one.
Yeah, but that setup is much more complex and can be used for many things. So it also has its benefits. As you can see,
for everyone who doesn't know, Memgraph supports styles. You can style the graph inside Memgraph Lab when you're using it. You have it on our docs. You just search for the Memgraph styles, Memgraph Lab styles. And there's the whole syntax, how you can generate your own styles. You can put your own icons. They can be different icons for different nodes with different labels. You can customize the size of the nodes. As you can see here, they're customized by the size of the PageRank. It's a little square root
It's the
It's a
same
crazy
so-
formula. It's a crazy scaling formula, but it works. So it's actually here. We could just use it without it. We could just use it with rank, but then some nodes would be disproportionately large, and you would have a tough time seeing them on the graph. But here with this formula scaling, you can actually get some reasonable size going to not have some miniature nodes here.
Yeah.
This is
The best thing
kind
about
of,
the best sorry
go
the,
ahead,
the best thing about that style is that it's a full-blown language, so that's why you can apply square roots, multiple division, property, whatever. So it gives you like full ability to style the graph and put various stuff inside. It's not just like applying a property on a node and that's it. Sorry, Ivan.
Yeah, this is more or less it about the styles, as you already mentioned. There are lots of different options, and as you can see, just applying the small image to the nodes, it takes literally one line. So it's pretty user-friendly and straightforward. If you grab one of these examples, I think you can implement almost anything by yourself.
Nice.
Okay, so now that you
So-
can see the graph, let's dig into the code a bit.
As
just
we've
so
been
I can
talking, I think more data has been coming in. Maybe we can
Yeah.
just show
Switch
the app
back.
again. Let's see how that works.
Okay.
Oh, now we have
Ooh.
some interesting connections going on. And these are obviously some very important people, the ones who are the largest ones. Awesome.
But it is an interesting network, so this definitely looks way different than this. So okay, let's dig into the code just a bit so I can show you how easy it was to accomplish it. The whole PageRank calculation, the setup for it, it's located in the backend service server setup.py, and PageRank is here. This is literally it. So this query sets up the module. This is the length of the random walk that's used to approximate the PageRank. And this is the probability to end the walk. So it's 1 divided by this number. For example, this was 0.1. It will have been 10. So most of the walks that will have been used to approximate the PageRank will have been of length 10. You can check up the documentation. It's probably going to make much more sense. And this other query, it's creating a trigger. So each time there is an update in the database, so a vertex is created, an edge is created, deleted, the PageRank is added to the node. So in the form of this property, .rank. This is it. Otherwise, you will have spent a lot of hours coming up with your custom code, implementing it. It doesn't matter which language. It's always a hassle. I think this is much friendlier.
So essentially, when you call PageRank online set, you set the parameters, which is later going to be used by the PageRank online update call. And then this trigger essentially runs every time you run a transaction and you update the data with created vertices, created edges, deleted vertices and edges. You actually run the PageRank online update, and it will give you a list of updates that you need to do. And this set command sets the rank of each of the updated node, the nodes that need to be updated with its rank. So it's essentially adding a small write to all of your write queries. So you run a write query, and then you get a small write query that runs immediately after your query, but essentially in the same transaction. So the data is consistent. So always, so there's no situation where you see the node and then it doesn't have a rank and then it gets the rank later. So it immediately, as the node is created, you get the rank. Am I correct?
Yep, and this behavior has actually enabled us to create this other trigger. It's called created trigger, which fires after the commit. It literally sends every new created object to a Kafka producer, so we can forward it to the backend app, which is then sending it to the React frontend. So
So that's how we get the live updates.
Yep, yep. And otherwise, it wouldn't have been possible. So if this wasn't before the commit, we couldn't have used this trick to make our life easier.
Awesome.
Could you open the publisher module really
Of course.
quickly?
So we are now going into the Memgraph service. It has, what did you say, publisher module?
Yeah. The thing that is
Okay.
pushing data back to Kafka, I think.
Here it is. So the
So
only
it's just-
thing it checks is if it was a created vertex or if it was a created edge. It takes the properties, maps them to a dictionary, and then we send it in the form of a JSON to the Kafka
So yeah, that's
cluster.
a regular JSON push to Kafka back,
Yeah.
and then it's consumed.
And
Yeah,
this is also a Memgraph procedure, the same as all of the MAGE modules. They are also built as Memgraph query modules, procedures, and it's just a different kind of procedure.
Yep, I'm gonna actually show you the transformation procedure. It's the one that's used to map the incoming data into Memgraph. So once you're receiving data, streaming data, you need to tell Memgraph how to create nodes and edges from it. So this twitter.py transformation uses the incoming data to create new nodes and relationships between them. So here you can see a user being created with a merge clause. So if the user already exists, it won't be created. If it doesn't exist, a new one will be added to the database, and a relationship of the type retweeted will be created between those two users.
Awesome.
Pretty
Nice.
simple setup. Okay, this is more or less it on the PageRank
Pretty
side.
simple but effective.
We can just try to return a few more nodes, given that it has been streaming for quite some time now, and see if there are any major changes in the network.
I feel if we forget about it, your computer is gonna boil.
Uh-huh. Yeah, I also feel.
But
like
who is
that.
this?
I mean, I hear it.
Who is this very
This-
important user?
World Music Award, but we can actually check if this makes sense. So we can go to Twitter and see if the account is legit. Okay, so 380,000
It possibly has a lot of
followers.
retweets.
Okay.
Okay.
But thank you for the data, World Music Awards. You deserve a follow.
It was something something Christmassy.
Okay, so that's more or less it on the PageRank side. Do you have any questions?
Let's see if there's questions in the chat. No questions in the chat, just a bunch of cool people joining in. Hey there. There's some new faces that I haven't seen before.
New faces, I try to nudge, but yeah.
Good stuff. So now that we have determined what is the most important account, most important node in this graph, the next we are gonna do is some community detection. We're trying to detect some of the communities that are forming inside the same network, I presume.
Yep. Now we're gonna use the same data set, most of the setup as well, and just run the community detection query. So create again the setup and the trigger, and Memgraph is gonna take care of everything else for us.
Awesome. Walk us through.
My screen. Let's again start with the same run script, just to get everything built, and we are again gonna start the front-end service by ourselves.
A lot of Docker compose. Docker is composing the magic.
Yeah,
all the time.
What would life be without Docker? The community.
Horrible, horrible.
The community detection algorithm is pretty simple in its way. How it works is that every node is assigned a separate community at the beginning, and then after some time, through iterations, each node learns which community it belongs to in regards to every other node around themselves. So they check if most of the nodes around them are part of one community, they're also gonna switch it up, and so on. And after a few, let's say 100 iterations, we're gonna get a stable set of communities and clusters. I think that's literally the simplest explanation I could have come up with.
It's a good explanation, but I'm looking at your terminal. Bind for 2181 failed. Port is already allocated.
You have to
So I probably
remove-
forgot to,
Yeah.
yeah.
stop the
So-
previous thing.
I was in,
But that's like, what is that? That's the Zookeeper. 2181.
no,
I think.
Memgraph, because Memgraph needs to bind to the port 7687.
No, but try
and it
look at the other window.
No, the other window. There is the
not
window
tab,
behind.
the window behind. You're
Okay.
clicking tabs, but the
Okay.
window. So bind for 2181 failed. Port is already allocated, but what is 2181?
We're gonna do a Docker compose remove for stop, and everything is gonna be stopped.
Now that's Ivan's favorite command.
Yep. I try to do it as much as possible so I don't end up with these messages ever again.
And the Buddha, you're right.
Nice.
It is Zookeeper. It's the Zookeeper port.
Yeah. That should be soon replaced with internal Kafka service or something. I'm not sure 100%, but yeah, as long
Very
as
much
that's
looking
the
forward to it.
I guess Zookeeper has become the necessary evil. They just have to run.
it's also quite important problem with consensus and keeping the services like in a good state. So it's not a bad thing, but yeah, there is some overhead.
Okay. Everything is started on this side. I can power up the front end app, and it said, okay, Docker compose. Third time's the
Compose.
charm.
Third time's the charm. Take it easy.
Nice.
We have
Aliases.
we have all
But
night.
you're like here. You are in the Windows terminal. That's the Windows PowerShell.
Yeah, because when I'm working with Git repos, I always have the problem of line endings, and I just didn't fix it, so kind of sticking to Windows PowerShell for now.
Does PowerShell has these aliases like Linux, or I actually never use that. So that you don't have to type a bunch of stuff. But not now. I'm just asking. General question.
Haven't tried it out, but I definitely should. Good note, Buddha.
Nice.
No, this is
Nice.
the old PageRank. We are still waiting on the reload. Okay, community detection.
What are some aliases? Let's engage the community a little bit. What are some aliases that you're using? If you're using any aliases, type them in the comments or in the chat.
Good question,
My
good question, yeah.
aliases are all about Git. So I have GA Git add. I have GC Git commit. I have GP Git push. Two-letter. I have all of the two-letter abbreviations.
I'll
DCU
show mine.
Docker compose up.
I'll show mine later when I'll presenting stuff. So
Okay,
until
so
that,
as you can
put in the chat. Yeah,
As
move
you
on.
can
Sorry.
this demo is a bit simpler, so the only thing you can watch out for is the color coding of the nodes. Nodes of the same color are part of the same community, and this is calculated by their similarity.
I can't say that I did notice that they look like Christmas lights. I guess this is either intentional, which is a pure genius, or not intentional, which is still a pure genius.
You'll have to thank
I like
Kata
this.
for it. Given that
Kata always bringing the Christmas spirit.
The PageRank example had a Memgraph color gradient on the nodes, and I think this could have been Christmas inspired.
Christmas gradients.
If we wait long enough, Christmas tree will emerge.
Yes. It's like the advent of code.
Don't bet on it. Let's try it in Memgraph Lab again.
For the next live stream. I think that's the goal for the next live stream.
Yeah, some advanced layouting and stuff for the lab.
Advanced layouting. How many accidental streams do you have to push in order to get a Christmas tree stream? What are the number of combinations? You know that problem, Marko, like with the monkeys and typing a Java program? How many monkeys does it take to type a valid Java program? Randomly bashing on the keyboard.
No idea at the moment.
Well, for everyone else who's interested in this, we'll find out for next time, or we'll forget and we won't tell you. But if someone is good at math, type it down in the chat or the comments. Sorry, Ivan, for the interjection. Show us what you got.
We are making your job harder.
It's okay. It's
every day
way easier to set everything up. So as you can see, again in Memgraph Lab, it looks pretty Christmassy, at least in my opinion. Here the communities are a bit clearer. For example, this one, World Music Award, as I could have guessed already, the most influential one in our scrape network. All of the communities were calculated correctly, except this one outlier. And all of the other ones are also part of pretty consistent communities. We can try to run it again on a bit larger sample.
Yeah, we should get a little bit more data.
Yeah, and it's also all about the hyperparameters and parameters that you set at the beginning when you call the module. Each dataset is different, and the parameters need to be tweaked. You need to experiment with them a bit to come up with the best possible combination. That's where the documentation will come in very handy. And of course, you can always ping us on Discord and ask us directly. I mean, we can always take a look at your dataset and try to provide some advice. About the setup. It's pretty simple, given that I already showed you the PageRank one. Here, the only other difference is that we are using these queries. That's it. Like, we only need to call the community detection online module, again with a set procedure, because we need to provide some information about the data set. The parameters I already mentioned, for example, is the graph we're dealing with weighted? Is the graph we're dealing with directed or undirected? Once you set this up, it creates a context for the module, and then again we can create a trigger that's gonna fire every time a vertex is created, an edge is created, or an edge is updated, a vertex is deleted, or an edge is deleted. Once it fires, it returns to which community a node belongs to. This is the community ID, a simple integer, and we just set the property cluster of that particular node to that community ID. As you can see here, World Music Award belongs to the cluster 3, and so do all the other ones who have retweeted World Music Award.
Maybe an advanced questions, but do clusters ever change? Or if you get assigned the number 3, you're never getting another ID?
So I would say in this case, it's not gonna change because this is we know already that this is the most influential node and this is the one that's connecting all the others. But in a few other places, yeah, it could change. For example, if 2 or 3 new nodes were added to a minor cluster and they had different IDs, they could propagate their values to the rest of that small cluster.
So I think how the dynamic community detection works, it randomly assigns the label to a new node, and then that can propagate. So you don't know exactly. There is no the exact number of clusters, I think, in the algorithm.
And if 2 clusters merge, then I would assume also there's some way how they get a node, get a common ID, I'd say.
Yeah, that's like the thing propagates. So yeah, these 2 nodes. I mean, the nodes from these, like let's say there are 2 big clusters, and then that merge in one cluster. All the nodes will have the same label.
Let's try to run it again on a bit larger sample size, 200. Should take 3 to 4 seconds.
And it almost looks like a Christmas tree. It just looks like not this one, but the one in the web app.
Yeah, if you look long enough.
You see what you want to see.
If you look long enough, and if you put like a triangle in your field of vision, it somewhat looks like a Christmas tree.
Yeah, the issue is, I think I'm actually not sure. I have to check that. So what happens if you remove an edge from a big cluster? In that case, like the community should be like detached. Like there should be a split in the community. So I think I'm not sure how we cover that, but let's check that. And if someone needs that, chat and question.
Yeah, and we can definitely try it out sometime in our next live stream. We can do a let's try to break our modules live stream.
Yeah. For example,
that's more or less it on the community detection side.
Bringing chaos into the modules. And speaking of chaos, has anyone watched the 2nd season of Witcher?
Is it already out?
It is.
It is.
Out.
I got a recommendation, but haven't checked yet.
Dominik, did you already watch it?
I'm not sure how to answer this question, but yes, I have. It was.
Did you find the time?
It was a weekend binge on 1.5 speed, just to get to the end faster. But it was
totally
it was nice.
Approved.
Lots of chaos. It was totally worth it. Can't wait for season 3. And it's somewhat crazy that you have to wait so much time. But yeah.
Even can you go back to the code, to the Python code, since you're switching the demo? I think, like the one that has a class. Yeah. No, stay here. So just to note, here you are actually using Memgraph client, Python Memgraph client to execute these queries. Maybe a question: why didn't you use the GQL? You have GQL Alchemy here.
It is GQL Alchemy.
But it's underlined.
Yeah.
Is it not being used?
Because I am running everything inside of Docker and I didn't even bother installing any Python packages locally. I just do it with Docker. I'm that crazy of a fanboy. Yeah, thank you for pointing it out, Dominik.
But you don't get autocomplete then. How can you live without autocomplete? You're too good. You're too good of an engineer to need autocomplete. I just can't.
No. But I want to say, GQL Alchemy is a convenient Python library that can be used to execute these queries. But there is no yet support for this advanced stuff like triggers and a bunch of stuff. But that will all at some point soon end up in the GQL Alchemy. So the job of
Spoilers.
Yeah. The job of writing these things will be massively improved, but stay tuned for that.
Yeah, I mean, this is already pretty simple, writing Cypher queries. As you can see, they are pretty straightforward, easily understandable, but it will help if we could just use GQL Alchemy to do it in Python.
Yeah.
And that's it on the community detection side. The last one we have to show is the node2vec algorithm, or rather the dynamic version of the node2vec algorithm.
Well, yeah, what would the world be without some graph-based machine learning? If you look hard enough, most of the machine learning papers published today have some sort of a graph in them, so it's a great time to get into the graph-based machine learning. And similarly to other algorithms, we also made it dynamic, online, incremental, and it works treat. And we can use it to do some interesting link prediction stuff. Yeah, lots of interesting stuff. I won't spoil it too much, so I will again call out Ivan to show us the demo.
Yeah, you're probably already fed up with me, but bear with me for just this last time. So again, we are starting our setup with the same script, building all of the containers. This time we don't have a front-end application. We're just going to be showing through Memgraph Lab what's happening, what node2vec is actually doing, and how we can use it to do some link prediction on the same data set. We are again in the Twitter Christmassy network. So currently building everything. The containers have started. Okay, and because we don't have a front end, there's just one small request I have to make to get everything started. Okay. And now, yeah, data is being ingested into Memgraph Lab. Now you will see the count going up, nodes and edges. So first, let me show you. This is the same data set. So users that are retweeting each other. We are gonna run the Cypher queries needed to set up node2vec by ourselves. So you have them in the README. This is the first one. I'm gonna go through it and explain what's happening. So we're just gonna call the node2vec online module. It already did a lot of pre-computing in the background as nodes were arriving, and now we're just gonna assign the embeddings it calculated to the nodes in the form of properties, embedding properties. Okay, it finished correctly. Now for the second one, we are gonna use a custom-made link prediction module, and what we're gonna do is create the predicted edges between the nodes. So we have the current relationship of the type retweeted, and now we are gonna create predicted, because we are using node2vec in collaboration with a link prediction module that we wrote ourselves to try to predict these relationships. It's gonna take
Awesome
a few seconds.
sauce.
We're gonna go into the code. It's gonna be a bit clearer. And now maybe I can just type it up.
Don't.
I wanted to type something else.
The easy one.
Yeah,
Okay.
the easy one. So as you can see, it looks a lot different because the algorithm came up with predicted edges between the nodes, and this query right here should tell us how many of them match to the actual edges between the nodes. And as you can see, it did quite well. At that point in time, we didn't have 30 nodes in the data set. And as you can see, our link prediction came up with a lot of the same links between the nodes. So what I did was match the predicted ones, and
Yeah.
as well those that have the real retweeted edge between them.
Match when you have both of the relationships at the same time. So that means the retweeted exists at the same time as predicted.
Yep.
Question.
I have a question. Are the datasets and codes presented or shared to the public? They are.
Yes.
And let me just go to my code. There we go. So here is the Twitter network analysis.
Let me just jump in for a second. You're gonna have to give us a few minutes after the live stream to push the latest changes, because quite some coding was done before the actual live stream, like in the hour leading up to it. So if you want to work with the latest data set and the latest code, definitely wait till the live stream is over.
As it goes with the live demos, after the live demo, so take a hot cup of coffee, take some eggnog or whatever your favorite thing for Christmas is, take like 15 minutes and the newest code will be up, I think.
But yeah, pretty good question. I'm not sure if I mentioned it, but to those of you who may not know, node2vec is used so we can calculate vectors from nodes. So in the simplest terms, we know how to do some simple machine learning stuff with vectors, and we want to do the same with graphs, but it is a bit more complex data structure. It doesn't fit well. And that's why we're transforming nodes into vectors. Again, by using random walks, as with everything. At least for this release.
Random walk, the most useful graph algorithm of 2021.
Who would have thought? So yeah, that's it also on the node2vec and link prediction side. We presented you 3 online or dynamic algorithms we have implemented, added to the MAGE library. You can try them out. All of them are live. The documentation is live. Check them out. If you have any suggestions, if you have any procedures that you think are missing or could be more useful, definitely hit us up with an issue on GitHub. We'll be right on it.
Nice.
Awesome stuff. So that's the trifecta of having the dynamic PageRank, dynamic community detection, and dynamic node2vec all in one demo and on one dataset. You can see these are extremely useful stuff. You can go to the Twitter network analysis repo and download the code. And for Memgraph 1.1, I think what we would recommend people go today is to try it out. Go Docker run the command, and the entire Memgraph platform gives you lab, gives you Memgraph, and gives you all of the MAGE modules bundled. So that's going to be your go-to to check it out. And before we leave you today, Marko has something interesting that he was preparing for us. So, Marko, I want to give you your screen, and I will share you, so you can show us what you've been cooking.
Yeah, I'm gonna switch. Hopefully that's gonna work. So yeah, since out of this gang, I'm the biggest Rust fanboy. So yeah, I have to show something on that side. So in the meantime, so we released MAGE 1.1, but there was a substantial change in the API, and then we were not atomic, but the delta t in time was quite fast. But eventually we've ported all the MAGE stuff, all the MAGE API changes to the Rust part, and I quickly today built a small example of a random walk, since we are talking about random walk a lot these times. in Rust. So essentially, it's a very simple thing. We just create another Rust library project in the MAGE. Basically, we link the library code, the RSMGP sys, and there is also some kind of some dependency on that side, but that's quite easy. Then we have a lot of these imports. I'll try and figure out how to simplify this code here, but essentially it's just importing all the stuff used later down in the procedure, and essentially the random walk is quite simple. So it gets the procedure gets like a start node and the length of that path that will be returned from a graph. And then here is a little bit of Rust magic, like creating a path and then fetching the vertex and putting that vertex into the path and all these things. And here is essentially everything required. So we just take all the outgoing edges and then randomly pick one of these edges and putting the two vertex to the path. And that's essentially it. It's quite short, I would say. There is the boilerplate around, but we're gonna simplify that in the future. And let me showcase really quick how that works. So I have a simple graph inside Memgraph, which is essentially like a super small graph. We have two paths essentially because this is the initial node and all the directions are here in the same direction, let's say in this direction. And if we run the random walk stuff here, initially we got like the path that has only two nodes, but if we run
that
this
exciting.
Yeah. What can you do? You have to start small.
Not exciting when you get only two nodes, but that's why it's random.
That's why it's random. Yeah. Now we get like three, and then if we repeat a couple of times, like two.
What is the most you can get?
Three.
What
Three
is the
because
most you can get?
3 because I'm starting from one of this one of a node with ID 1. So only
okay.
two are like we just like flipping the coin and we get one out of these two because it depends on the first branch, like what's the first edge that is picked.
Exactly.
And
I love
yeah,
the fact that we are ending with a random walk module.
Yeah, people usually randomly walk around. And yeah, that's more or less it, I think.
What would you say is the biggest upside to using Rust with Memgraph?
I would say Rust has a pretty good trade-off when it comes to speed and simplicity, let's say. Even though Rust has some, it's like the compiler forces you to do a lot of work to actually compile the program. But at the end, it's quite simple. The Rust program is quite simple, and at the same time, it's quite performant. So Python is usually slower compared to C++ stuff, and Rust is somewhere in between when it comes to the complexity and the speed of execution.
So it sounds like a small trade-off for the benefits of both Python and C++.
Yeah, that's nice. I would say like that. But yeah, various people, various opinions on that topic. But yeah.
Yeah, to me, I think safety, data races, stuff like that's very interesting with Rust. How Rust helps you write better code.
Yeah, for example, in this line here, I'm referencing this edge here, but somehow I ended up using that edge down here outside, or the vertex. I use this vertex outside of the loop because actually I have vertex here, and if you put a reference here, then you're referencing something which doesn't exist anymore in the second iteration, and Rust informs you about that early on. So you really cannot make error on that side.
Yeah, it's a little verbose, but I think it's worth the trade-off.
Yep.
Awesome.
All right.
Anything else? If nothing else, then I'm back showing the presentation. So back to our call to action of the day. Go and try out the Memgraph platform with the new dynamic MAGE. We can't wait to see what you're gonna build. And of course, when you build something, I just have to change the slide. When you build something, you should go to discord.gg/memgraph and tell us all about it. We have a very vibrant community there, 400 plus members and growing strong. So go showcase your work, and we'll be happy to see what you build.
Yep.
Last words.
Happy to help with anything as well.
Our DevRels, Ivan and Katerina, Kate, they're going to be hanging out on Discord. Happy to help if something's wrong. Also, half of the Memgraph team, at least the ones who are on the engineering side, will be hanging out and helping out. And you can also see Marko sometimes when he's not busy coding the random walks.
Yeah, from time to time, wild random Marko appears.
Yeah. But Dominik, you were quite quiet during this live stream with horns and stuff. So yeah, where is the?
I forgot. I think we should give ourselves an applause and shout out to Marko for reminding me about the sound effects that I should have used a little bit more. And I have to add some for the.
Thank you, Marko, for not reminding him earlier.
Evans is the eternal hater of the sound effects, but what can you do? Different people, different opinions. Some of them matter, some of them don't.
Okay, gonna mute myself.
He was gonna mute himself. All right, so I think this concludes our MAGE 1.1 live demo stream. Thank you everyone for joining. I think we'll all have a drink now, maybe even together. And see you on the next launch, next release, next live stream. We'll prepare some awesome content. Until then, sign up for our future live streams. Subscribe on YouTube. Leave us a like. We like when people leave us a like on our streams. And that's it. Peace out. Bye everyone.
Have a good holidays, all these things, and yeah, enjoy.
Happy holidays.